In this video, we are going to be taking a look at elapsed time. Now, the essential question that we are going to be focusing on throughout this video and that we're trying to solve is how can you solve elapsed time problems by converting units of time. Now, I want everyone to turn to page 431 in your math book, and we are going to unlock a problem. And the first thing we want to do is look over the question. And it says a computer company claims its laptop has a battery that lasts 4 hours. The laptop actually ran for 200 minutes before the battery ran out. Did the battery last 4 hours? Okay, now first of all, we need to figure out a couple things. Right at the top at page 431, you can see that it's asking you for how many minutes are in 1 hour. Now we know this is pretty simple. 1 hour equals 60 minutes, and we'll just write that right on page 431. I'm going to move this question over. We can think about this problem a little bit more. So we need to set up a division problem before we even know how many hours and minutes 200 minutes equals. So we have our total amount of minutes, what we have here, and let's write this together. We have 200 total minutes. And we're trying to figure out how many hours and minutes are in 200 minutes. So we are going from a smaller unit of measurement to larger, so we are going to be dividing. Okay, so 200 divided by 60. Okay, and we can work this problem out, and that would give us 3 hours, 20 minutes. Or 3 with the remainder of 20. Okay, so 200 minutes equals 3 hours, 20 minutes. Okay, so let's take a look at this step number 2 now. Okay, so it says compare, right, greater than, less than, or equal, okay, to this. So we see that 3 hours, 20 minutes, okay, is less than 4 hours. Okay, now we can move on down here. So it says since 3 hours, and we'll fill this in, 20 minutes is less than we'll write that in 4 hours. The battery, we can answer our question now, did not to squeeze mine in, last as long as the computer company claims. Okay, so we've answered our question by solving or by completing step number 2. So now we're going to take a look at the try this part at the bottom of page 431. It says Jill spent much of her summer away from home. She spent 10 days with her grandparents, 9 days with her cousins, and 22 days at camp. How many weeks and days was she away from home? Okay, so the first thing we need to do is we need to add 10 days plus 9 days plus 22 days. Okay, and that will actually give us 41 days total. Okay, so now what we need to do, we need to figure out, since we're trying to figure out how many weeks and days was she away from home, we're going to convert the days into weeks and days. Okay, so we're going to take 41, which is the total number of days, and we're going to divide it by 7 because there's 7 days in 1 week. Okay, so we can have 41 divided by 7, we know is 5 with a remainder of 6. So we can say, so Jill was away from home 5 weeks and 6 days. So you can see we just divided because we were going from a smaller unit of measurement, which was days, to a larger, which was weeks. 5, remainder 6, so 5 weeks and 6 days. Okay, now we're going to take a look at a number line to find elapsed time. Okay, so we can see that the question here is Monica spent 2.5 hours working on her computer. If she started working at 10:30 a.m., what time did Monica stop working? Okay, so we know she went 2.5 hours. Okay, so we know, first of all, using a number line here. Okay, so we've already gone 1 hour. Okay, 1 hour from 10:30, 1 hour would be 11:30. Write this in here. Okay, so that's 1. Now we're going to go another time here. Okay, plus another hour. So 11:30 plus another hour will give us 12 o'clock. I'm sorry, 12:30. Now we're just going to go another half an hour now. And we know a half an hour added on to 12:30 would actually give us 1 o'clock. Okay, so we have our 1 o'clock here, and we can see that, so Monica stopped working. We know that Monica stopped working at 1 o'clock. Okay, now another way to solve this problem would be using a clock. Okay, so we can see that if Monica spent 2.5 hours, we can see that going around one rotation or 1 hour would put us at 11:30. Another whole rotation would put us at 12:30, and then finally, if we're going from that 6 to a half an hour there, that would actually put us at 1 o'clock there. Okay, so we could easily see once again that Monica stopped working at 1 o'clock. So let's take a look at finding a start time now. Okay, so it says Robert's soccer team needs to be off the soccer field by 12:15 p.m. Each game is at the most 1 3/4 hours long. What time should the game begin to be sure that the team finishes on time? Now we know that 1/4 of an hour equals 15 minutes, so 3/4 of an hour would actually equal 45 minutes, so that's something that we need to know right from the beginning. Okay, so what we need to do first of all is subtract the minutes first. Okay, so we are going to take the minutes here, so 45 minutes we're going to subtract, okay, from that 12:15, and that's actually going to give us 11:30 a.m. Okay, and then after that we are going to need to subtract an hour from there, and that's going to give us 10:30. Okay, so the game should begin at actually 10:30 a.m. Now I want you to complete this problem all by yourself. When you press play, I will have the answer for you. So you can see the answer for this problem is 2:35 p.m. So I want you to convert 3 years and figure out how many days that equals all by yourself. And when you press play, I'll have the answer for you. So you can see that the answer is 1,095 days. I want you to complete these 2 problems all by yourself. When you press play, I'll have the answers for you. Here are the answers to your final 2 problems, and this is how you find elapsed time. If you have any questions about this concept, please come and see me.